welcome to the Astro. So in this Python tutorial, you are going to learn that how to read and plot fixed file image from ASTROSAT UVID telescope. So this ASTROSAT telescope is in a space and it is launched by Indian Space Agency called ISRO. So and it works in the also in the UV regime, ultraviolet regime, and X-ray and other bands. So our purpose for this tutorial is to read and plot feeds image from this UVT telescope. So UVT telescope has like two filters, NUV and FUV filters. Okay, so let's do it step by step. Okay, so for your convenience, I have done these plotting and reading fits image uh, in smaller steps. So we have total step 7. So first we'll read fits file, then we'll get some information about fits file, that whether it's an image or it's a table file. Then we'll get some information about the fits file. So basically this would be like header. This would be your header information. Okay, so we'll get some header information about the feed file. Then we will extract 2D image data. Then we will see that how the pixel intensity distribution looks like, and then we'll plot the feed image in a pixel space or coordinates xy. And next will be to plot your feed image in WCS coordinates. So WCS stands for your World Coordinate System. So let's do it one by one. Okay, so first we'll read feeds file. Okay, so for doing that, you need to import some libraries. So library. So first import Astropy. So from Astropy dot input output import feeds. Okay, so this will deal with feeds file, and then we'll import matplotlib for plotting. So import matplotlib dot pyplot as a plt. So this will deal with plotting, and then we'll import numpy. So import numpy as np. So this will deal with array. Now this much we have done. Now we'll read feeds file. So you can add here more. Okay, so now read feeds file. So for that you can type here file. So my file equal to, or file, you can give any variable you want. This is like user variable. So file you can type and then type feeds dot open. Okay, then you can give your file name as a string. So you can give file name dot feeds. Okay, so in my case there is already a feeds file present in my directory, so I will just go here and I will check it where it is. So this is my feeds file. Okay, so type here file dot info and run it. So here you can see that This image contains only like your image primary HDU, and here 0 is for your primary HDU, HDU, and HDU stands for header data unit. So this is information about your object, that it is present in your primary HDU. Now get header information about the header file. Okay, so for that type here file 0. So 0 for your primary, and then type your header. Okay, so here 0 for primary. Now run it. Okay, so here you can see that there is a lot of information about your feeds file, everything about the observation. That, so let's check it some crucial information about the feeds file. You can see that it's like a feeds format, and it is like 2 data float. It has 2 axes, x and y, and the rows are like 4800 pixels, and columns are same 4800 pixels. You can see telescope is like ASTROSAT, instrument is UVIT. You can see the date of observation, the time ends. You can check the array object name R005. You can check its array deck, nominal pointing. You can check the observer name is like Kanak, and it's an NUV filter. You can also check for your source ID, observation ID, target ID, observation number. Then you can look for your X size, Y size, pixel size, exposure time. You can go for your date. We got it. Then we can object array deck. You can also look for your yeah, so these things you can get from the information, and this is like your matrix to convert pixel to your world coordinate system. Okay, so let's do it. So this much we have done. Now extract 2D image data. Okay, so our image data is in primary HDU. Okay, so for that type here data equal to file 0 for primary, and type attribute dot data. Now run it. Okay, so if you run the data, okay, so if you print the data, this is your data type. Okay, it's a 422, and then you can get a shape if you want. So shape, you can see the shape is 4800. Okay, so these are 2D image data. Print. Now we have read our data. Okay, you can also print your data if you want. So we have extracted the 2D image data. Now we'll plot that how the pixel intensity distributions looks like. I mean, most of the pixels have like 0 values. Okay, So this looks like this. Now, okay, so for that, type here plt dot figure, and then you can type, then you can plot histogram of pixel intensity distribution. Okay, distribution. So for that, type here plt dot hist. Okay, and then give your data. Okay, so this is like your 2D data. So convert convert 2D data into 1D data. So for doing that, you can check data 1D and type here np dot ravel, and you can pass your data. So this will convert into your 1D numpy array. Then you can pass your data 1D, and you can give bins equal to say 500. Then you can show your plot. Okay, so you can type here plt dot show. So here you can see that this is your plot. Okay, so this is your plot, and you can see that most of the pixels intensity are like coinciding with your 0 0. Okay, and there are other values from 0 0 to like 0. Okay, so these are the values. So most of the like pixels are like near to 0. Okay, in your ccd. So you can type a title here plt dot title, and you can call it your pixel intensity distribution. Okay, now you want to upload your 2D fits image in pixel coordinate. Okay, so like you have a 4800 into 4800 rows and column. So for that, type here plt dot figure for a new figure, and then type here plt dot image. Okay, so other like plotted plt dot plot. So for 2D data, plt dot plot does not work. So you have to show using image show and pass your data. Then type plt dot show. Now run it. Okay, so here you can see that the picture is not showing anything. Okay, so this is like the scale is like your linear. Okay, so but our eyes are like logarithmic in the nature, so we have to plot this image on the log scale. Okay, so for that, go above and you can import from matplotlib. So matplotlib dot colors import log norm. Okay, so this will like plot intensity on log scale. Now plot and add here norm equal to log norm function, and now run it. Okay, so here you can see that you can see some features in the image. So earlier it was like blank. Now, so when we have like plotted on the log normalized scale, it is showing some features. Can I add some color bar? Plt dot color bar to it and run it. So here you got a color bar, and if you zoom it, you can see some features and you can see some galaxies. Okay, by zooming it, so go back, and here is one image, also a galaxy. You can also zoom other portion. You can see the features in the image using log norm. Okay, now you can see that the origin, at the origin, like your image origin is not coinciding, so it's like 0 0 is not there. Okay, so like 0 0 like your left upper part. Okay, so for doing that, type here origin comma origin equal to lower. Okay, so then you can observe that now your origin is at 0 0. So earlier like it was like reverse of your y-axis, so now it is at 0 0 origin. Okay, you can also change some color map. You can give color map to this. So you can give color map equal to, you can give say gray, so black and white. Okay, so you can see it is black and white image. You can also give it a jet. So this will appear like this in the color wala scale. Here is your galaxy. You can also give rainbow. There are a lot of color are present. So now it looks like this. So for me it's like jet is fine. Okay, so like you can also like now you can also like plot a portion of this plot. So suppose I want to plot data from 200 to 400, 4000, 4800. No, yeah, and then uh, 2000 to 4800. Okay, so here you got a portion of the sky. Okay, you can make it more. You can go to more if you want. You can go to 1000 and 1000. Okay, so like here you got a portion of the sky only. Okay, rest is cut out. Okay, so from, you can see it's 700 to 1800, 1000 to d2. So you can give here 800, 800 to 1800, then 1000 to 22, 1000 to 22. Okay, so here you can see that the image is here. Okay, maybe you can go 500. Let's change it. You can see some features. So here you can see that you can go. Okay, so this way like you can control like the pixel space of your image. So for time being, I'm just plotting. I'm plotting the whole picture. I am not slicing. Okay, so let's run it once again. The whole code. Okay, so you can see your image here. Now, so from header, you can do one more thing. You can from header, okay, like you can get some information. Say you can go here, type header, and then you can extract your from header, and you can get your array of the object. Mm, okay, so header. Yeah, okay, so you can get, say you want to know your what is your x-axis. So 2, you want to know your observer. Okay, so you want to get your say instrument. So compose this keyword and go give a bracket and give a string as an instrument. So it's a VIT. So this way you can access, or you can also access using like giving keyword say 0. So it's a 1, it's a 2, it's a 3. So you can also access it's a 5, it's a 17. So you can obtain that what what its header contains information using indexing, or directly you can like put your um, a string value in that keyword and you will get. Okay, you can get one more if you want. You can also get. Okay, so I will start. I want to know that telescope. Okay, which telescope is this? Also I want to know the object. So I will copy here and I will type string and object. So it should give like R005. So this is like your data information. Okay, so this way you can extract and you can use. Now we have plotted this image in your what we call in your pixel space. So you can give a title plt dot title plt dot title, and you can say it's a image in pixel space. Okay, now same things you can do in using like WCS coordinate means RD coordinate. Okay, so for that just copy everything and paste here and type here plt dot uh, subplot and give projection equal to WCS, and before that you need to import some libraries. Okay, so let's import some libraries to plot image in WCS coordinate system. Okay, so we have to extract WCS from your header information. Okay, so for that, type here from Astropy dot WCS import WCS. Okay, and then you get your WCS header information. So you get WCS, then file 0 dot header, right? So you got your Astropy. So if you print WCS, you can see here WCS will remove these things, not so. So I will put here WCS. So you can see it, they're like your conversion from array deck to your from pixel space to your like array deck in your image. Okay, so for that, okay, so this we have done, and type here in WCS space. Let's run the whole code again. Let's wait. Okay, so here you can see that this image in icon of pixel space. Okay, and this image is in your WCS space. So you can see that it's like your array, and this is your deck position. You can see that 27 degree 35 seconds, and seconds, and like it's a 12 hour 0 minute 30 seconds, 11 hour 9 minute 30 seconds, 58 minute 30 seconds. So this is the coordinate. Okay, so this way you can add feeds file, read feeds file. You can also add some interactive control, percentage mat plotlive widget. So this will like add interactive control the plot. So run it. Okay, so here you got it. So you can zoom the image. Okay, so this way you can also move the image. You can move the image.